Welcome to Industrial PLC Applications. This video is in the First Look series and takes a look at block instructions. After completing this video, you should be able to identify block instructions used in Connected Components Workbench and identify the input side, the internal workings, and the PLC output side of a block instruction. Up to this point, you've been working with instructions that operate on a single bit of memory or data. Direct contact, reverse contact, direct coil, reverse coil all work on a single binary digit, otherwise known as a bit. This is fine when dealing with true or false logic solutions, but they do not address instructions that contain or need to control more data. Furthermore, some instructions require greater amounts of memory and CPU allocation to perform their operations, like timers. Timers, for example, require a greater amount of memory allocation because they have many variables to monitor and control. Each new variable must be set up and monitored while the timer is in operation. Clearly, a single bool will not be enough. A timer instruction is a small part of a larger family of instructions, which can control more than a single bool or even larger amounts of memory and memory allocations. Generically, they're known as a block instruction because all of the pertinent data to be monitored and controlled are held within the block instruction, and each instruction has inner instructions and actions that take place to complete the instruction and solve the logic. So let's look at a hypothetical generic block instruction, one that will represent the basics of any block instruction. First, it's easy to identify since it looks like a box. Every block instruction will have three sections: the input section or side, the working section, and the output section or side. The configuration, the work performed, and the end result will differ depending on the instruction selected, but all block instructions have the input left side face, the inner workings, and the output result right side face. So let's look at the input left side face. All instructions need to have an input connection, the monitored condition that will activate the instruction. Notice the line leading into the block. This is the preconditioned checkpoint. If the value of this point is false, then the instruction will not begin. Many blocks identify this point as .in. The input left side face is the read side of the instruction. Once triggered, the instruction must refer to the values located in the user programmable boxes. There can be 1, 2, 3, or more input variable input boxes depending on the instruction used. Unlike the in, these values are the stated target or comparative value of the instruction that will be needed in order to execute the instruction itself. The bottom input box is where the data pointer is set up. A data pointer is the constant or variable the instruction will use for comparison and execution. A constant, for example t#41 seconds, is one that cannot be changed by the logic execution or manual intervention. A variable is an assigned memory location that holds the current desired value, but it can be changed by other logic. The variable must be a compatible and suitable data type for use within the instruction. For example, you can't put rocks into a milkshake machine and expect any good to come out of it. If it is a timer, then the data type entered here must be a time data type. A variable, for example egg time, can be substituted for the constant t#3 minutes, but must be of the time data type or match the required data type. Each subsequent box will have either another operand or a different function, such as resetting a counter. The center block is the inner workings of the instruction. Anything from measuring time to comparing relative values can be within this section of the instruction. Although you cannot see any moving parts, you can observe the current program values. These values must be the same data type in order for a true comparison to be determined or an action taken. The right side face is the right side of the instruction, as in writing an instruction, changing its value. This is the execution side of the instruction. The bottom side box will show you the current value being monitored and used to determine whether the instruction is complete. The upper wired output is true when the instruction has completed its task. With all block type instructions, the left side is the monitored input side. The block itself is the action to be performed or checked, and the right side is the resulting output side. Each side block on the left will require input from the programmer for the instruction to function properly. Each side block on the right will be for monitoring only, as the programmer cannot write to this location. Each block will have an output, but some may not be visible. On the right-hand side, the value shown in the lower box is written by the PLC. If a variable is entered, then the data collected will be written to that location as well as the instruction's internal variable storage. The result of the instruction is wired through the instruction's output, normally defined as .q. Be aware, however, that some block instructions do not have a singular Boolean output, but rather a resultant that is stored in another memory location. For example, a math instruction output. This has been another one of our first looks. Thanks for watching. Be sure to subscribe to keep more videos coming.